Okay, good evening, ladies and gentlemen, and welcome to this Saturday evening session on Lean Six Sigma, Green Belt and Black Belt coaching. So today we are going to discuss about the control charts for the continuous data. Okay, so before that, anybody new in the room, let's welcome them. And then, yeah, okay, the chat is not yet activated. Let me just quickly activate it. Okay, here we go. Yes, it is activated, right? Superb, superb, superb. Good evening, good evening, good evening. Anybody new in the room? First time attending, just type me in the chat box. First, we will welcome them and then we will start our session today. Chaliye, fatafat, just type me in the chat box if you're attending this first time, okay? Generally, Saturdays, we don't have the new people coming in, but again, if anybody, bhula bisra koi to, welcome all new guns. All right, Raj ji ने already उनको welcome कर दिया है. Okay, but I think nobody's new gun here today, I believe. All right, chalo, let's begin our journey about the control chart. Now, control chart is a very, very important tool, by the way. This tool has been picked up from Statistical Process Control, SPC. Okay. Now, what happens is Lean Six Sigma basically is kind of all the tools picked up from various, PDCA and then Pareto's and then Fishbone from Ishikawa and then from, SPCC control chart. So all these are various tools which we have basically we have gathered, meaning the Six Sigma, the fathers of Six Sigma basically gathered these tools. And yeah, who is father of Six Sigma, by the way? Yes, anybody knows who is father of Six Sigma? Type in the chat box. Meanwhile, let me open my whiteboard. Okay. Anybody who is aware of who is father of Six Sigma? Bataiye, you can make mistakes here. We are here to learn. You can type in the chat box, by the way. Type that in the chat box quickly if you are aware of that. Yes, nobody? Ishikawa, no. Ishikawa is not Ishikawa. Anyone else? I'm talking about Six Sigma, not Lean. Lean है तो Japanese नाम आएंगे. What about Six Sigma? Okay. Sagar ji is not. Yeah, this is a green belt session only, but it's not like first, second, third, but it's good important topic for the green belt. Okay. Ha, exactly. Ramanuj ji has got a right answer. Bill Smith. Okay. So Bill Smith basically built the Six Sigma model first. All right, just for your information, Bill Smith, he was from Motorola because Six Sigma originated in Motorola. So after Bill Smith, Bill Smith basically built a model called AI model. It's not artificial intelligence. It's not Air India. It is analyze and improve model. Okay, because by that time in 1980s, Motorola was struggling big time with their Japanese counterpart. The quality was not up to the mark. There were a lot of complaints about the quality, and then came the successor of Bill Smith is Professor Michael Harry. The name is Michael, Mikel, Harry. Okay, now he is a gentleman who AI meaning it is, in our DMAC framework, we have our define, measure, analyze, improve, and control, right? So out of which analyze and improve was the model built by Bill Smith. And after that, that model was improvised by Michael Harry with define and measure. What Michael Harry said, before we go to analysis of the problem, let's define the problem clearly and let's collect the data clearly about it. And that's where define and measure phase came into existence. And then came analyze and improve, AI. And after that, Michael Harry added control phase as well. So the total framework of DMAC is what is the gift from Bill Smith as well as Michael Harry. Both were working for Motorola together at this point in time. Okay. The yellow belt, green belt, black belt, master belt, all this was done by Michael Harry only. Okay, just for your information. Are you clear with this? Just type yes in the chat box. This is a good information, new information for you. see, we should know the history of Lean and Six Sigma. Okay. I will give you the Lean's history someday as well, but today let's focus on this. So, uh, so today's topic about control chart. All right. Control chart is, uh, yeah. Can you please mention the reference also from your given notes? Important topic. So this is, so that's what I'm referring. So this topic particularly we are discussing here. This topic will come in the major phase, first of all. So today's topic you will find out in the green belt major phase. Make a note of this, as well as control phase. Okay. Green belt mein major phase as well as control phase, you will find the control chart topic available. All right. So these are the two phases in which we are using control chart. Now, why do we use control chart? What does it do basically? That is something which we are going to study. Okay. Now, so let's understand this control chart which we are discussing today. Okay. Which is a part of a grand scheme of statistical process control, SPC. All right. The inventor was, anybody knows SPC ka inventor, control chart ka inventor? It was Walter Shewhart. Make a note of this. Just for our understanding, Walter Shewhart basically propagated this theory after studying lot of processes. What he said, any process, okay, any process which flows between, understand this. Let me first define this. Define the control chart and then we'll make the control chart. Okay. Any process, let it be a manufacturing process, let it be a service process. Once we collect the data from the process, now I'm talking about a continuous process. Okay. A manufacturing plant which is continuous, or let's say there is BPO, which is, on a continuous scale, you are just, addressing the phone calls of inbound, customer complaints or something like that. Okay. So you are just measuring, you're just monitoring all the data. If you plot those data on the graph, okay, let's say if it looks like this. Okay. Now this line is called the average line, which is X bar line. Okay. And this line is called as control limit. It's called as upper control limit. And this line, the bottom line is called as lower control limit. Okay, just for your information. The formula to calculate upper control limit is X bar plus 3 standard deviation. And formula to control, formula to find out lower control limit is X bar minus 3 standard deviation. Okay. Now let's do one thing. The board is not visible, is it? Is my board visible to you? Because I have got two screens in front of me and it is visible. Just give me confirmation if you're not able to see my whiteboard. Are you able to see my whiteboard? Just give me yes in the chat box. Okay. Yeah, Radha Krishnaji, what you can do is just, if you're on the mobile phone, just switch the other screens if you have multiple screens. Or let me just stop sharing this and share it once again. Okay, so that if there is any glitch, but see, a lot of people are observing that it is there. It is. So just check out that now. Okay, na? Okay, good. Super. Yeah, so what I was talking about is, this is the basic fundamental control chart. You just plot your process output. Let's say production data. You're just plotting your production data. All right. Or any quality parameter. You're just plotting that quality parameter being monitored. Okay. As far as the time is concerned. So what happens is you measure the X bar. X bar is nothing but the average of all the data points. Then UCL, which is upper control limit. And then comes the LCL, which is lower control limit. Upper control limit is X bar plus 3 standard deviation. Lower control limit is X bar minus 3 standard deviation. Let's calculate this. Okay. Imagine there is one process where X bar is equal to 30 and standard deviation, which is sigma of that particular process, is, let's say, 5. or let's say 2 for that matter. Okay, 2. Can you just calculate upper control limit and lower control limit for me? Can you just do this mathematical calculation for me and give me the answer in the chat box? I've given you the formula. I've given you the numbers. X bar is 30 standard deviation. Is 2. Very simple calculation. Can you just quickly give me so that your funda should be clear? UCL is 36 and LCL is very nice. Everybody is clear with this? Just give me yes in the chat box. So 30 plus 3 standard deviation. That means 2 into 3, which is 6. So 30 plus 6 is equal to 36. And 30 minus 6 is equal to 24. Everybody is clear? Anybody who is not clear, let me know in the chat box. Anybody in the room who is not clear with the simple calculation and formula? If you're not clear, don't hesitate to say no, okay? Sabne answer diya does not mean you have to be with the same pace. Okay, I will be very patient. Let's ask the question. Clear hai? Very simple. Now, what Walter Sheward says, now understand this. What Walter Sheward says, any process which runs between +3 and -3 standard deviation, it's called as stable process. Stable process. Any process which runs through this band of +3 and -3 standard deviation from the mean, it's called as stable process. The process stable meaning you can say predictable. It is very predictable process. Are you understanding? So any process which goes through this, it's called as a stable process. Are you clear with this? Just give me yes in the chat box. Everybody clear hai? This is called a stability. So control charts are basically, talking about stability. Not clear? Okay. According to Walter Sheward, any process which runs through this band of upper control and lower control limit. So not a single data point going beyond this limit. If any data which goes beyond this limit, that means this process is not stable. Okay. Now, if any data which goes beyond this control limit, any control limit, okay, either above or below the lower control limit, okay, it can be like this as well. It can be like this as well. Any data which goes beyond, upper or lower. Now, this is called as spatial cause variation. Make a note of this. I'll give you example, practical example. Spatial cause variation. And any variation which is running, see, variation is there within the band as well, right? So this variation is called common cause variation. Make a note of this. Common cause variation. मैं explain करता हूं. Just make a note of this. Just make a drawing. If a single data point goes beyond control limit, upper control limit or lower control limit, that data point is called spatial cause variation. First, write this down in your notepad so that I'll explain you. And any variation within this upper and lower control limit, that complete variation is called as common cause variation. That, normal, natural variation also will be there because variation is a nature of nature. We all know that. We cannot eliminate variation from the universe because this is a fundamental part of the universe, fundamental principle of the universe. And if it is between the upper and lower control limit, that is common cause variation. If it goes beyond upper or beyond lower control limit, that data point becomes spatial cause. That means there is something special has happened. For example, what is special? Your regular 5 to 10 minutes delay. Now understand, it's a very simple example I'll give. Your regular 5 to 10 minutes delay of your office arrival time, it's common cause variation. But when your car had an accident and you reach 1 hour late or 2 hours late, or you had a car, your tire got flat, tire got punctured. That is where the special cause variation, where you reach 1 hour delay to your office. That is called special cause variation. Your body temperature in the common scenario is called common cause variation, because there is always a fluctuation. During the day also your body temperature fluctuates. It's a common cause variation. But if I collect the data during your fever, that is called special cause variation. It will be a little higher than upper and lower control limit. Are you clear with these two examples? Just type yes in the chat box. So सुरेश जी का एग्जाम्पल है, speaking on the phone, speaking on the phone with your wife is common cause variation, the heartbeats. Speaking with the girlfriend, if you are specially married, it's a special cause variation. That's a very funny analogy. Okay. Are you understanding this common cause and special cause variation? Just give me yes in the chat box. Clear hai? Everybody with me till now? Everybody's clear? So common cause, special cause समझ में आया? Now the question comes, why 3 standard deviation only? Why not 4 standard deviation? Why not 5 standard deviation? Why not 1 standard deviation? That must be the question, correct? Why Walter Shewhart decided only between +3 and -3 standard deviation our control limits will be set? Why not 2 standard deviation? Why not 1 standard deviation? Why such a... So the answer to that, make a note of this. Now you will not understand the meaning of the answer, but some of the questionnaires, some during the interview processes, etc., they ask this question: why the control limits are set at +3 and -3 standard deviation? The answer to that is it balances out. Just write this down. I'm not going to explain this today. I will take a special class because that will be a diversion. Okay. The answer to that is at +3 and -3 standard deviation. Okay. It balances out. It balances out. Write this down like this. At +3 and -3 standard deviation, it balances out. एक second. Let me just type the pen here. Okay. It balances out, write this down, alpha and beta errors. Make a note of this. Alpha and beta error of sampling. The answer to that is, ये पूरा रट के बोलना है. उसका मीनिंग मैं आपको बाद में समझाऊंगा. I'll explain it to you later. What you need to answer is, at +3 and -3 standard deviation, it balances out alpha and beta error. Now, what is alpha and beta error? I will explain you in a separate session, not today. Again, it will take half an hour, 45 minutes to explain. It balances out alpha and beta error. That's why it decided, Walter Shewhart decided, let's, between +3 and -3 standard deviation, if the process is flowing, that is called a stable process. If there is a glitch, then it is called as unstable process. Clear, everybody? With me, the fundamentals are clear. So we are checking the stability right now here. We are checking the stability of the process, whether the process is predictable. Okay, we have to monitor this, right? Very good. Now, there are generally 3 types, or maybe you can say 4 types of control chart when it is... See, what are the 2 types of data? Everybody knows continuous and discrete data, right? Just give me yes in the chat box if you are aware of this. Types of data. One is continuous data, which can be measured on a continuous scale, like height, weight, the speed, width, temperature, continuous data. Or you have a discrete data, like a count data. Number of people in the room. It's a count data. It's a discrete data. Okay. So, or male, female, pass, fail, go, no go, those kinds of count data is called discrete data. So we are talking about continuous data today. So when you have continuous data, you have got generally three types of eye chart or IMR chart, which all of them we are going to practice today on Minitab itself. Now understand this, when do we use this chart? When you have single sample taken. When you have single sample. Now what does that mean? Single sample meaning when you have single sample taken from the process, that is called eye chart. Eye meaning individual chart, and IMR meaning individual and moving range chart. Moving range. MR meaning moving range chart. All right. So the chart which I had plotted earlier, those upper control and lower control, actually that is called as eye chart. It is an eye chart, which is a basic chart, discovered by Walter Sheward. All right. So single sample meaning there are two types of sample. One is called you are taking one sample at a time. Okay. Let's say you are from a BPO. You are testing the quality of the person who is speaking with the client. So you take the recording of one call. So as a quality executive or quality manager, you take only one sample after a periodic interview. Maybe after every half an hour, you take one call recording. You just go through that recording and check the quality of that. That is called one sample at a time. Or in some cases, you get a group of calls. Okay, you take a group of calls, like for example, after every 1 hour, you take 3 calls or 4 calls for your checking. Or let's say you are producing something, either you take only one sample, single sample, or you take multiple samples. Clear? So I'm talking about single samples here. Are you clear with this sampling plan? Just give me a yes in the chat box. So when you have a single sample here, then eye chart or IMR chart is used. Clear hai everybody? Single sample. When the samples are very expensive, okay, lot of testing is required. So generally we take single sample. Anybody in the room are using single sampling strategy? Only one sample you are taking after some interval. Just give me yes in the chat box. Yeah, MR stands for moving range. Moving range. I'll explain you. Once we will do this data, then we'll explain. Anybody in the room who are using the single sampling strategy in their processes? Just type me in the chat box if you are using this. Are you using this? Okay. Satish ji is using this. Who else? Anyone else? Single sample. At a time, only one sample you are taking. That was single sample where you are using I and MR chart. Okay. Now coming back to when you are multiple samples, you are taking 4 samples, 5 samples, 10 samples at a time for quality checking. That is called multiple sample. That also is called as subgroup sample. What is that? Subgroup. Subgroup meaning more than one sample. Now, when it comes to subgroup sample, understand this. If that subgroup is, if that sample size is less than 10, we go for X bar R chart. And if your subgroup sample is greater than or equal to 10, then we go for X bar S chart. These are the only 3 to 4 charts we are using in the continuous data. Just make a note of this. That means if we are taking a group of samples, let's say that group of sample is, let's say 5, 6, 7, 8, etc. We will go for X bar R chart. X bar R meaning X bar is the mean and R meaning the range. So they are basically 2 charts, X bar and then R. R is the range, X bar is the mean. And second is, if your sample size is more than 10, then you go for X bar S, which is X bar meaning the mean and S meaning the standard deviation. So because the logic is this, whenever the sample size goes beyond 10, standard deviation is a better indication than the range. Okay, that's the simple logic behind it. See, less than 10 के लिए भी हम लोग standard deviation use कर सकते हैं, but generally X bar R से काम चल जाता है. Okay. So is it greater than 10 in the third ones? Yes. So it is, okay. Thanks for the, that's my mistake. This is, yeah, the symbol should be ulta. Thank you very much. Thank you very much, Preeti, for this correction. So it should be greater than or equal to. ऐसे लिखिए. हाँ, correct. Done, everybody with me? Super clear. Just give me yes in the chat box. The both are under single sample or one. So single sample के लिए only I chart and IMR chart. When you have multiple samples, if they are less than 10 samples you are taking, go for X bar R. More than 10 samples you are taking, go for X bar S. Clear, everybody? Just give me yes in the chat box quickly. Super clear है ये? Very good. Amazing. Okay. So let me share one Minitab file with you. We will first do some Minitab exercise. And after that, we will go for, I will go deeper into these concepts. Okay. Can I just quickly download this Minitab file? Let me also open this. Once you have opened it, let me know in the chat box. Okay. Done. No, Momita, it's not a problem. You can just open that. No issues. Yeah, which version you're using, Rajesh ji, for Minitab? Our own version, which we have here, then it should support. If you have any other version of Minitab, then it may not support. किसका open हो गया है? Just give me yes in the chat box. Okay, for the new people, you should have Minitab installed on your laptop. Okay. Okay. Done. Okay, जिसके इसमें कुछ प्रॉब्लम है, just observe what we are doing. Okay, कुछ लोगों का हुआ है. Let me just quickly give you another file if possible. No issues. Okay. Open na, हाँ. Try this one, which I'm giving. Just try this one. The next one is the same file from some other source. एक बार इसको ट्राई करके देखिए. चलिए, ओपन. कुछ लोग का ओपन हो रहा है, कुछ लोग का नहीं हो रहा है. So Momita, Rajesh, and who else is struggling to open? किसका ओपन हुआ है? जस्ट गिव मी यस इन द चैट बॉक्स इफ यू आर with your laptop or desktop. Okay. Joel has opened, Ria has opened, Ashutosh, Sanjay, Ranjit, Ranjan Das. Okay, a lot of people have opened. Some people have not yet opened. Okay, एक काम करते हैं because so एक काम करते हैं, just share the screenshot on this number ना, so that we can diagnose your challenge. Okay. हाँ. I hope you guys are opening with a laptop. Okay, mobile में नहीं open होने वाला. It's not on mobile, right? It is on the laptop which has Minitab installed, which is coming from our system. Okay, then only it will be opening, right? Okay, Sadanand ji ka bhi open ho gaya. ठीक है, चलो. Okay, or the people who are struggling, there are 2-3 people who are struggling. Nonetheless, just focus here what we are doing, because otherwise हमारा time भी उसमें चला जाएगा. What I will suggest, just we will investigate your challenge separately with on this number. Okay, इंडिविजुअल आप सिर्फ स्क्रीनशॉट लेके ना उस पे भेज दीजिए कि दिस इज द चैलेंज विद योर विद दैट फाइल व्हिच सपोर्टेड. ओके, सपोर्टिंग फाइल का. ओके, चलो ओपन करो. या कृष्णा जी, आई हैव जस्ट गिवन द फाइल वंस अगेन. कैन जस्ट क्लिक एंड डाउनलोड. So the file is about chocolate weight, and these are the samples. So these are subgroup samples are also there because there are 10 samples they have taken. Okay, but now understand this: if these chocolates are individual chocolate weights, then we can go for eye chart or IMR chart. Okay, if these samples are of, what you can say, if these are subgroup samples, subgroup meaning you are taking the 10 samples, 10 chocolates at a time. After, let's say, every 1 hour, you are taking 10 samples and checking the weight of the samples. That is the case. That is called subgroup sampling, where we'll go for X bar R and X bar S chart. Okay, so first we'll go for eye chart, eye chart and IMR chart. Right. So how do we go for it? Stat, control chart, and you can see variable chart for individuals. Stat, control chart, variable charts for individual, and there you will find IMR chart. You can just select that IMR chart. Stat, control chart, variable charts for individual, IMR chart. Okay, just click on that. This window will appear. I once again repeat: stat, control chart, variable charts for individual, IMR. So we'll check the first. It's a combination of eye chart as well as MR chart, both. So we'll get 2 charts, basically 2 graphs. So select that and just select the chocolate weight here. That's it. Okay. Done, everybody. So we need not to select the sample column because we are doing individual chart. So individual chocolate weight will be plotted here. Okay. And click on OK. Everybody got this graph? Just give me a yes in the chat box. Very nice. Super. So just try to, so this is called eye chart and this is called MR chart. Eye chart and MR chart. Now, this UCL, this formula I had explained you, X bar plus 3 standard deviation, and this is X bar minus 3 standard deviation. Okay, तो ये upper control, lower control को catch करता है. Now, in this, are you observing one data point is just on the boundary of upper control limit? UCL के boundary पे, right? So this is called as variable. समझा नहीं मैं. What is that? Variable. So upper control, you want the path of it, is it? So we want to say go to stat, control chart, variable chart for individual IMR. Look at this. Control chart में variable chart for individual, because we are I for individual, no? I for individual, MR for moving range. So individual moving range chart. So yeah, so just click on that and select chocolate weight and click on OK. That's it. Chocolate weight को double click करो. You'll get this. Okay, यहाँ पे आप click करोगे तो chocolate fat यहाँ पे आएगा left में. Just click on that. It will get selected. Click on OK. Once you do that, you'll find out these two graphs. Now, whenever there is any data point, as I said, any data point which is going beyond control limit, it's called what? Type in the chat box. Very important. Any data which goes beyond control limit, it's called as. Everybody's clear? It's called as what? Special cause variation. Very good. So out of this 120 data points, special cause variation, only one data point is just on the boundary line of control limit. Just on the boundary line of control limit. That's why, okay, even though it is on the boundary line, it is kind of one data point going ahead. So this requires investigation. So investigate. What happened here? What exactly went wrong at around 55 number sample? Was it because of some process variation? Was it the machine problem or a man problem? So investigation meaning simple. Any control chart investigation requires fishbone and RCA, root cause analysis. Fishbone followed by RCA. Clear, everybody? So investigate meaning ask the question why this data point has gone up. Was it any machine problem? Was it any material problem? Was it any man problem? Was it any measurement problem? What exactly is the problem? And go for root cause analysis. Now here in the moving range, what is moving range, by the way? Moving range is nothing but the distance, the difference between consecutive data point is called as moving range. The difference between consecutive data point is called as moving range. That means how close the process is moving. It's called the moving range. So here you can see here the first data point is this, which is just below 2, okay, 2 grams. All right. The third data point is this, which is second data point is this. So that means the distance between two consecutive points has reduced. Understand this? So first data point was a little higher. Second data point is lowered. That means the distance between two consecutive points is lowered. Okay. The third data point goes a little above. That means the distance has gone up a little. Okay. So this shows how the process is moving consecutively. Here also there will be control limits calculated and you can see 3 data points going beyond the control limit. So this process is not stable process. Clear hai? So if we investigate individually, this process is not stable process. Are you clear with this? Just type yes in chat box. If I individually calculate this process is showing one data point in the I chart, individual chart, and 3 data points in the MR chart, which are going beyond control limits. So this process is not stable, requires some investigation, the root cause analysis, and we have to take action to bring the process in the stability part. Clear, everybody? So this is called IMR chart. Any doubt in this, please let me know in the chat box. So these are two charts we are plotting. One is the individual points, and then that consecutive differences of the individual data point is plotted in the MR chart. Clear hai? Just give me yes. Any doubt? See, no doubt meaning two things. One, you have understood everything. Second, you have not understood anything. So type 1 if you have understood everything. Type 2 you have not understood anything. Everybody type 1 or 2 in the chat box. So let me get the confidence that okay, you guys are understanding what I'm talking about. Okay, very good. Super. Chalo. So this is about individual moving range. Is it the variation between the nearby values? It is the variation between the consecutive values. For example, let me go back to the data. Okay, individual chart is very simple, which is plotting individual values like 42.1. So it will plot 42.1, then 40.7, then it will plot 40.7, then 40.3, it will plot 40.3 like this. Okay, it's an individual plot, correct? What happens with the MR chart? MR is a consecutive differences. For example, what is the distance between first two 42.1 and 40.7? The distance is 1.5. Are you understanding this? The distance between first and the second point is 1.5 grams. Correct? Yes. So it will plot 1.5 in MR. So MR में वो plot करेगा, first plot करेगा 1.5 को. Okay, let's say if I plot 1.5 here. Then what is the distance between 40.7 and 40.3? दोनों का distance क्या है? The difference is 0.4. Yes or no? So from 1.5, it has dropped to 0.4. So it will plot 0.4. Then what is the difference between 40.3 to 42.3? The difference is 2. Now it is going from 0.4 to 2 here. Are you understanding? This way it is plotting one by one the MR. Clear? It is consecutive points ka difference. It is plotting. And if the difference is more, that means it is indicating some shift. More the difference, that is indicating the shift in the process. Are you clear with this? Just give me yes in the chat box. Very good. Amazing. Now with the same data point, let's find out if I take the subgroup. If I take the subgroup of this, subgroup meaning you can see here, if you can see here, I have taken 10 samples at a time. This is first 10 samples. Then these are the second 10 samples. Okay. Let's say let's take the first 10 samples, out of which what I will do, I will take the average of this. So 42.1, 40.7, 40.3. So I'll add them up and take the average. That will be X1 bar, the first sample ka average. Okay. Similarly, so I'm talking about X bar R chart. Okay. So what is the range, by the way? Yeah, MR is the difference between two consecutive data points. I for individual data points. I meaning individual data points plotted. MR is the distance between two consecutive points. Clear? Ranjit, clear hai? So your answer is MR. MR is the moving range. How the range is moving? Range matlab kya hai? The maximum minus minimum, right? So in the individual, there is no maximum, there is no minimum. There are only two data points. So what is the range? The distance between these two data points is called the range. Okay. And how it is moving? That is called moving range chart. Now coming back to X bar R chart, where we are taking the group of samples, not individual samples. We are taking group of samples. So first we'll take the average and then the range. Range is what? Maximum minus minimum. So here, what is the maximum value in the first sample? First set mein, what is the maximum value? Type in the chat box. What is the maximum value of the first 10 samples? Just observe closely. You will find 43.1. Correct? Everybody with me? I think that is the 10th sample. What is the minimum value? I think that is 39.6. Are you with me? So 43.1 minus 39.6. How much it is? It is, I think, 2.5, I believe. Correct? So the range will be 2.5. So X bar is the average and the range meaning the difference between the highest and the lowest. 3.5. Right. 3.5. Correct. 3.5. So X bar meaning X bar is nothing but the average and the range meaning the difference between highest and the lowest. So both will be plotted. X bar also will be plotted like this. And the range also will be plotted like this. Now understand this. If this is my process, I am interested in the mean, which is my X bar. Now this is very important analogy. Understand this. Because if this shifts, let's say mean shifts, I will make more defect on this side, right? If mean shifts on this side, I will get more defects on one side. Yes or no? Everybody understood this? If this is my specification limit, which customer gives me, I will accept the product between this and this range. If my average, the mean shifts, the center shifts, okay, I will start creating more defect on one side. Yes or no? Correct? If these are the specification limits. So I have to monitor my mean. Are you understanding? Apart from that, I need to monitor. Apart from that, I need to monitor. Let's say this is my process. Apart from only mean, I need to monitor the maximum and the minimum range as well. Because range is what is showing me what is the spread of the data. So range and standard deviation are showing the spread, and both are very important, right? I need to monitor the spread and I need to monitor the center. So X bar is monitoring the center of the process and range is monitoring the spread of the process, the variability of the process. Are you clear with this? Just type yes in the chat box. Ye clear hai? Just give me yes in the chat box. Everybody. Is it clear to you? Super clear? Yeah. So when I say X bar meaning what? Is the mean. Yes. So mean is what is the center, correct? Yes or no? This is nothing but a center. No? This point is the center point, correct? This one. So we want to monitor where is the center of the process. Okay. And also we want to monitor what is the range of the process. What is the variation of the process? Because both these parameters are very, very important. Even the range shifts, I will create more defects. Even the mean shifts, which is the average shifts, I will create more defect, right? So both monitoring is very, very important. That's why we are monitoring X bar and R separately here. Okay. X bar is the center and the range is the width of the process. Exactly. Similarly, when the data points are more than 10, we can go for X bar and S chart. The funda is exactly same. X bar is checking the mean of the process. And because the number of sample size is more, so instead of range, we consider standard deviation of the data. Okay, so we will monitor X bar and the standard deviation of that process. Okay, so dono bhi karke dekhte, that will give you more clarity. Okay, first we will do X bar R chart. Let's go to stat control chart, variable chart for subgroup X bar R. Just follow this process. Stat control chart, variable chart for subgroup X bar R. Just follow this. Once you have opened it, let me know. Stat control chart, variable chart for subgroup X bar R. Opened, everybody? Done? Very good. Just click on that. This window will appear. Here, just select chocolate weight and its subgroup size, just select sample. That's it. So in the first option, just select chocolate weight and the subgroup size, select sample and say, okay, that's it. Don't do anything else. And you will find this data being plotted. Everybody got this? Just give me yes in the chat box. Yes, everybody? Very good. Yeah, 10 samples. Yes. So with the same, see, if you have less than 10 samples, go for X bar R. If you have more than 10 samples, go for X bar S. So I have taken exactly 10. So I can do X bar R, X bar S both. Okay. Generally, X bar S is more preferred. Okay. Now coming back to this. This is, for example, this is sample number 1. Okay. This is average of the first 10 samples. Are you understanding? Are you clear? So first 10 chocolate ka maine average liya. That will be this data point. Are you with me? Just give me yes in the chat box. If I put a cursor, it shows sample 1 and the mean is 41.32. आप उस पे cursor पे click करो, that will show you the number as well. 41.3. 41.32 is the average of the first 10 samples. Then this is the average of the second 10 samples, which is 41.65. Are you understanding? Average of the third 10 samples, which is 42.44. Average of the fourth sample. And similarly, so on and so forth. So we are going up and down. This is the mean of that. You can see the mean is 42.10. Now it is called as X double bar. Why? Because every individual sample is the average in itself. Yes or no? This is average of first 10. This is average of second 10. Yes or no? This is average of third 10 samples. And this number is average of the averages. And that's what it's called X double bar. Are you clear? Just give me yes in the chat box. Clear? Because it's the average of averages. Correct? Now, in this, any data point going above and below control limit? Any data point going above and below control limit? No. So the center, the average is stable. So the process is stable as far as the mean is concerned. Are you understanding? Okay, so the process is stable as far as the centering is concerned. Okay. Now coming back to the range, the maximum, and so within that sample, every sample, what is the variation? So here, so the first data point is the range of the first sample. Okay, which we calculated 3.5. Remember 3.6 or 3.5 calculate kiya tha? So this is the first point. Then this is the second point. So this is R1, which is the range 1. This is R2, which is range 2. This is R3, etc. And then we have taken the average of all the range, which is called as R bar, which is the average of all the range, which is coming to 4.992. And here also there is not a single data point going above and below control limit. So the range chart is also stable. So we can declare that this subgroup sampling process of the chocolate weight is considered to be stable for both this average के लिए भी and the variability के लिए भी stable है. Are you clear with this? Just give me yes in the chat box. If any data point would have gone above or below control limit, then we have to investigate it and take the action to bring the process again back in the control stage. Okay? Similarly, let's go for X bar S chart. With the same process, let's go for X bar S. Same procedure, go to stat, control chart, variable chart for subgroup. Below X bar R, you will find X bar S. Exactly same process. Nothing will change. Instead of range, software will calculate standard deviation of each and every subgroup sample. 10 chocolate weight ka wo standard deviation lega and it will get plotted. Okay. Are we looking at the mean of MRs in the sample? It is not MR, it is the range only. It is R only. Why it is called MR in the individual case? Because individual may there is only one data point, right? In this case, we have got 10 data points. So imagine the data here. Let's say you are a quality control inspector. You are a quality checking guy and there is chocolate production. Okay. So factories say chocolates are going. So every 1 hour, you come out of your quality checking lab and take 10 samples from the chocolate conveyor and go in your test lab and you check the weight. So you have got 10 samples. So you have got a highest weight of the 10 sample, lowest weight of the 10 samples. That is called a subgroup sampling. When it comes to individual sampling, you are just taking only one chocolate at a time. You are not taking group of samples at a time. Correct? And that's what it's called moving range. MR is considered for the individual data points and not for this. Clear? Are you clear with this? Just give me yes in the chat box. सुपर क्लियर है, ये डिफरेंस क्लियर है. Now you might have the process stable in the in the average, which is x bar, but process unstable in the variability. Yes or no? For example, let me give you example of this. Let me give you example. Understand this. You have the process variation like this. Okay. Everybody follow with me. So I've taken 3 samples like this, 4 samples, 5 samples. Everybody's average is exactly same. Everybody's average is exactly same, matching, but the ranges are different. Are you understanding? The variation is different. Every variation is different. Are you observing this? I've taken 4 samples, 10, 10, 10, 10, 4 samples. Every average is different. Average is exactly same. So my process is stable at my averages. X bar means I have got stability, but I may not get stability here in the range because this might fail. This has got huge variation. Are you understanding this? Just give me a yes in the chat box. This might go beyond control limits. Are you clear with this analogy? Just give me yes in the chat box. Clear hai everybody? Just a second. I'm not able to. I'll repeat again. I'll repeat again. MR between difference individual sample. Yes. Yes, exactly. Preeti, you are absolutely right. Nailed down. Okay. Now coming back to this explanation which I just gave. Now understand this. The process is, it's very simple. Just try to understand the fundamentals. Okay. This is the first process. The X bar is, let's say, 42. Understand this. X bar is 42. Point something, 0.1, 0.2, etc. And range is, let's say, 5. Okay. Second sample I've taken. X bar is 42 only. And the range is 15. Can you see the flatter bell-shaped curve having more range? Yes, everybody? My third sample, X bar is 42 only, 42 or 42.1, 42.2. Range is maybe 6. My fourth sample I've taken, X bar is 42 and my range is 3. Now, can you see this? My range is fluctuating. So I might get a stability here. In my X bar chart, I will get a stable process data, which is very close to 42, 42, 41, 42.42, like that. But in my range, I might get couple of data points going beyond control limits like this. Yes or no? Are you understanding this? Now this is 15, right? The second data point is 15. This one, this will definitely go beyond control limit because my control limit stops at 8.8. My control limit stops at 8.8. If my range is 15, it will definitely go beyond control limit. So my range chart will fail the stability test. X bar will pass, but my range chart will fail. Clear hai? Just give me yes in the chat box. Everybody, are you clear with this example? किसको पहले नहीं समझा था? Are you clear now with this example? So you might have stability in the X bar, but you might have instability in the control chart. Ronnie ji, I've just consider this data. I'm just considering 15 का रेंज हो सकता है. अगर 15 का रेंज है तो वो बाहर चला जाएगा कंट्रोल लिमिट के. And that means my process is unstable. Are you understanding? So एक सैंपल में अगर मेरा रेंज एक ही 10 सैंपल consecutive 10 samples में if the difference is 15 grams, that means there is something wrong with my process. Yes or no? Very simple. Within the 10 samples, एक चॉकलेट का वेट है let's say 50 and दूसरे चॉकलेट का वेट है 35 grams. There must be something wrong with my process. Yes or no? Are you understanding this? So this is what the data is exactly pointing out, that there is something wrong. Please investigate. Exactly the special cause. Exactly, there must be a special cause variation. Clear X bar R chart? Okay, now coming back to X bar S. अभी X bar S करेंगे, same funda, control chart, variable control chart for subgroup, X bar S. The same process will be followed. Select chocolate weight, subgroup sample, select sample, and say OK. And you will get similar kind of. So let me just put both these graphs besides each other. So on the left hand side, you have got X bar R. On the right hand side, you have got X bar S. Nothing much difference between these two. Only small difference between range chart and this is S chart, which is a standard deviation chart. Okay. X bar remain exactly same. The same data set has been used. So X bar is the same chart here and here. Only some difference between the range as well as standard deviation calculation. But X bar S is also a stable chart here. Not a single data point going beyond control limit. Are you clear? Just give me yes in the chat box. समझ में आ गया X bar or X bar S chart? Just give me yes. Very good. Now listen to me very carefully. Now listen to me very, very carefully. Okay? ये बहुत ही इंपॉर्टेंट है, आपके लिए समझना बहुत इंपॉर्टेंट है. This point. Okay? Now focus here, everybody. Everybody is completely focused here because this next 2 minutes explanation is a very, very important insight. Okay? It will open up your mind. Okay? Are you focused? Just type F in the chat box. F is completely focused. Just give me a complete focus for 2 minutes. Focus. Everybody with me? No distraction. Listen to me very carefully. Very good. Now listen to me very carefully here. Let's say, let me open only one graph. Okay, let me open only one graph instead of two. It will make a little bit of. So let me open up this X bar R chart. Okay. Now just focus here. If this data goes here, that means my mean has shifted. Yes, no. My mean has shifted. Yes or no? Correct? Correct? I will investigate and I will bring the process in the center. Yes or no? Just give me yes or no. So my job is to investigate and bring the process to the center. Yes or no? Very good. What will happen if the mean goes below lower control limit? Again, the mean has shifted to the lower side. So my work is to investigate and bring the process back to the center. Yes or no? Everybody with me? Clear? Coming back to the range. If the range goes beyond control limit, I will investigate and bring the range, within the control limits, within the center. Yes or no? Everybody? Similarly, if the range goes beyond lower control limit, I have to bring back to the center. Yes or no? Everybody? No. For the fourth question, the answer is no. Because when my range is dropping below lower control limit, that means my range is lowering. It is reducing. You don't make your range higher again. Keep it as it is. How many of you got the bulb on moment? Just type BO in the chat box. How many of you got bulb on moment right now? That's why I said just focus here what I'm saying right now. Have you got the bulb on moment? So if your process is going above control for the X bar chart, if your process is going above control limit, you take the action. That's what I said. Focus here. Focus here. Focus. If the process is going above control limit, you bring back to the process to the center in the X bar chart. If your process shifting on the lower side, you bring back to the process in the center, X bar chart mein. Clear hai? Okay. If the range, now understand this. When your process will go beyond control limit in the range, because when your range, your spread will increase, then it will go above upper control limit of the range. Yes or no? Ranjit ji and Sanjay ji, if the range is increasing, my spread is increasing, it will go above upper control limit. Yes or no? Everybody? Yes, just give me yes or no in the chat box. When my range is increasing, my upper, my range will go above upper control limit. But when my range is decreasing, it will drop below lower control, but I will not take the action on that. I will keep it as it is because I want my range to be as much less as possible. Have you understood this? So whenever your range is dropping below lower control limit, let's say lower control limit is at 1.1. If it is going below 1, 1.1, 0.5, 0.2, it's best for your process. So don't take any action. Lot of people make mistake here. They take corrective preventive action going beyond. Sir ने बोला है ना control limit के बाहर गया तो take action. No. X bar में yes, above upper and below lower control limit you have to take action, but not in the range and not in the standard deviation. Exactly, we want the range to be very close to zero. जितना lower है उतना अच्छा है. Lower is better. Don't bring it to the center once again. Are you clear with this? Just give me yes in the chat box. Are you clear now, Balbon? हाँ, out of specification जाने दो. Let it be go out of specification. Don't take any action. Let's keep it as it is. Slowly after some time, process will get stable at that level. Initially, it will go to out of control, but slowly the range will get stabilized. Clear hai? Just type yes in the chat box. Exactly, because our motto is to reduce the variation. कौन कर रहा है भाई ये? राधा कृष्णन जी, आपका आई थिंक स्क्रीन से ये हो रहा है. Are you clear? Just give me yes in the chat box. समझ में आ गया? That's it. That is what the control chart. The same goes with the standard deviation. The same goes with the standard deviation chart as well, correct? When your standard deviation goes below lower control limit, that's the best situation to be in. Don't take any action, let it be. You can investigate and understand what is bringing that result. But don't bring again back. Usko upar nahi uthana hai. We need not to push it again up. Okay? Let it go down as much as possible. And this is what is our logical thinking should be put into place. Software will show us control mein ya uncontrol mein. Does not matter. X bar uncontrollable hai, uncontrolled hai. So you have to take action, but not in I chart or not in range chart. Okay, range chart, if it goes beyond upper control limit, take immediate action. But if it goes below control limit, don't take any action, let it be. Okay. So that's it about the control charts. So we have studied what is the fundamental of control chart. Any process which flows below up, above and below the 3 standard deviation is said to be a stable process. Okay. Now anything which goes beyond control limit is called special cause variation. Within control limit is called common cause variation. There are 4 charts we have seen: I chart, IMR chart for the individual samples, and then X bar and X bar R and X bar S for the subgroup samples. Whenever we have group of samples, we can either use X bar R with the less number of samples, less than 10. If you have more number of samples, more than 10, go for X bar S chart. Okay. And we have seen with the help of Minitab how to conduct the stability test, the control charts. It only requires the practice. So I would highly encourage you guys to take your own data, your own process data, and practice with the help of Minitab and infer out of that. Okay, infer. What is your inference? What is your observation? Why this? So investigate why this process is going above and below the control limits, and that will give you the wisdom. All right. So any question you have, you can just let me know in the chat, or you can just raise your hand. And is it any relationship between the range and sigma level? Range and sigma level, which is both are basically indicators of variability. Let it be range or let it be sigma level, both are indicators of variability. But range is a very basic level, highest minus lowest. Okay, it's a very basic indicator, whereas standard deviation, which is sigma, is a better indicator of our variability. So If you have a choice between considering range as well as standard deviation, always go for standard deviation for, for variation, for variability calculation. Okay. Yeah. Can you help me to open Minitab? Yes. Let me just show you the process quickly to open the Minitab software. Now, everybody, the new members especially got the login ID password, right? Everybody, just give me yes in the chat box. Anywhere you find the date, any time you find a challenge, this is the number. Okay. Just send a text message, WhatsApp message, not SMS message. Just send a message that I am having the trouble over here, and then we will check out. Okay. Now look at this. Go through the course 1, which is the Lean Six Sigma Green Belt certification. Okay. Scroll it down. Below the defined phase, you have got the Minitab section. Okay. Here you will find this option called Access Minitab. Just click on Start. There is a small video you can just observe how to process that. And below the video, there is a folder which you can click on that and get the access of the software. Okay. If you find any trouble, take a screenshot and send it to our WhatsApp number, and our team will guide on that. Okay. Use your personal laptops and desktops, I would suggest, rather than your office laptop, because then it will have the IT permission, etc. Okay. Yeah. See, Ronnie ji, all the data which we are giving you now, every data point is available in your Minitab, in your curriculum. Okay, I'll show you. Where will you get these data files? Okay. So I'm coming back again to the green belt. Okay, and see, generally the Minitab starts in the major phase, right? So in the major phase, you can see here. So this is a major phase of the green belt. And these are the topics. Let's say, for example, look at this. So this is from where we start understanding the data variation, etc. Okay, so measurement system analysis, sampling, etc. So let's say, for example, time series plot. You can see here time series plot here. Okay, and there is a time series plot Minitab exercise. If you click on this time series plot Minitab exercise, click on Start, you will find all the Minitab files of time series plot. These are all files downloadable. You can just click on them and you can download them. Okay. For example, the right now whichever file we have used, let me see where you can locate that file in your. So look at this. So X bar R, we have studied X bar R exercise, right? So this is X bar R exercise. You can just start on the exercise format, and you will find multiple files of X bar R. You can see here. Okay, so just click on that and you will find this file, whichever I have just shared with you. Okay, clear? So everything whichever is there is already available on your folder or your LMS folder. Okay. Yes, how to submit the notes before examination. So you can share the notes in any format. It can be PDF format, PPT format. Okay. So any kind of format you can use. It can be mind map format. See, notes are for you. Okay, because we have the open book test at the end of the your course content, right? So these notes become very handy when it comes to the attempting the examination. Notes will be very handy in front of you, just to recheck your notes, rechecking your answers. Okay, and there are some sample notes which are given. So you can just refer those sample notes and submit accordingly. Okay, there is no hard and fast. It is not mandatory to submit, but that is recommended because then mentors will have the confidence that you have understood the entire concept and you are ready for the examination. Okay. By the way, we will be having our green belt upcoming hackathon. Okay, certification hackathon, the first week of May. First week of May. The dates will be communicated to you later. All right. Send a data chart, send in WhatsApp group. WhatsApp पे नहीं जाएगा ये because those are the Minitab files. No? So WhatsApp will be not be compatible to handle those Minitab files. Okay. Clear? Yes. Any question? Somebody was asking the question in between, right? Haji. Anybody unmuted who wanted to ask the question? You can just raise your hand. If you have any question, you can unmute and ask the question. No question? Okay. So before I close, we have the yellow belt session coming up tomorrow morning. Okay. And if you know, we have the 40% referral bonus scheme. So if you refer your friends, colleagues, okay, you get 40% referral bonus, right? So better you bring a lot of your friends, colleagues into it. Let them, okay, don't do it for money's sake, but let them also get the advantage of in their career. Even one career you change by referring them to this course or this lean six sigma journey, then that will be great help in their career. Okay. So I would highly recommend you, highly encourage you guys to send a lot of people in our yellow belt sessions so that they also will get a new way of looking at the career, new pathway of the career. If they're frustrated, not growing in their career, okay, the salary is not growing, their cadre is not growing, promotions are not getting, and they have lost their job. So those people, you just ask them to join our yellow belt session. Even some of the people got the job opportunity, job offers with our free yellow belt certificate as well. Okay, it's very powerful, so don't miss that opportunity. All right. Yes, very interesting session, na Preeti. Thank you very much for the and very nice that you guys are attending this session live, asking the questions, interacting, and your quality of the questions are very good. So it shows your commitment. All right. Super. Onboarding process, radio pharma. Do you have any tool to handle these kinds of issues? Yeah, Vinodji, why don't you send a message on the WhatsApp number and then we will sort this out. 248. Okay. So okay, then we will have a to and fro interaction if I'll require some more information before I give you the answer. Yeah. Ha. Yes, yes, yeah. Not you should, you must. You must attach in your resume. ओके येलो बेल्ट ग्रीन बेल्ट ब्लैक बेल्ट रिज्यूम को फ्लॉन्ट करने के लिए तो हम लोगों ने सर्टिफिकेट दिया है आपको ओके इट्स सीएसएस accredited certification so it's a globally recommended certification absolutely you need to attach this okay so Ranjit ji we are having upcoming hackathon which is on the first week of May that you can attempt or you can check the recording in our green belt course itself at the end of the course you will have the hackathon recording so you can refer that as well so both options are okay for you okay either you can attend live or check the recording okay it's a same effect you will get so before giving the exam you must go through the hackathon at least once either recorded or live okay but that will be my recommendation then there is a sample questionnaire also you can go through before giving the examination okay then prepare yourself go for the examination timing is absolutely flexible because you guys are from different time zone different culture different shifts okay so it is not like ye is din mein is time pe exam hoga it will be completely flexible okay so we have people from all other countries as well so time does not matter you just send a message that I am available between this to this and please arrange our examination and our team will arrange for you all right guys so I think if the questions are over, thank you very much for joining in. We'll connect again on Monday with a new topic with the same enthusiasm. Till the time, keep learning and keep growing.